What's up, everyone? This is Isaac, your favorite AI animator. We've got a very exciting video to do today, an exciting tutorial. We're doing the AnimateDiff Unsample tutorial. This is probably one of the best animation tools that's out there. So we've generated images, just random images that we can use. We have also done talking heads, right? Or at least talking faces. And that's for scenes where somebody's just talking back and forth, right? Not much movements. You're just trying to convey some message. And so we were using live portrait for that. That was the workflow for it. This workflow, the AnimateDiff workflow, is actually for a variety of movements. So if you're doing a fighting scene, this is the workflow for it. If you're doing any major movements or sporadic movements, this is the workflow for it. It captures many different movements, and it can be really hard to do, but only because of how flexible it can be. Let's jump into our ComfyUI workflow and we'll get started. And boom. So I'm going to start you guys off here with just the generic default workflow. And it's always good to cover the basics. So I'm just going to jump over what these things are doing once again. And these are all the default things that ComfyUI comes with, by the way. So we've got our checkpoint loader. Again, if we think about this as the brains, because this is the thing that loads all of the models that we have on hand. And the models are trained on specific information and will tell the model or will tell the workflow or the AI what to do because it's trained on particular images, right? If it's trained on blonde women, then it'll only produce blonde women. If it's trained on black folks, boom, you get black folks. And so we think about this as the brains of the operation. And then we've got our text encoders, which we always want to color this one green, and we're going to color this one red, just so that they're easier to understand. And we're going to, the clip text encoders basically are a way for us to talk to the AI, right? Because it won't understand human language. So we're converting human language into something the AI can understand. That's what the text encoders are. So it takes our text here, and this is what we want in the video, or in the what we want the AI to generate and what we don't want the AI to generate. Whether it's a video or an image or whatever, this is how we tell it what to do. So we've got the case sampler. The case sampler is like the heart. And this is where AI does all of its work. We don't exactly know what it's doing, but again, the way we like to think about it is like it's really like noise. So it's like it's throwing a whole bunch of noise, a whole bunch of crap at the wall, and whatever sticks, and it'll just keep throwing stuff. So it'll just keep throwing crap at the wall, and eventually some shapes will start to form, and depending on whatever the shapes are, the AI will make something into it that looks like an image that we can understand. And the empty latent image, again, is it's just noise. It's just random noise. So we're just giving noise a shape, and we're going to throw it, and we're going to say, hey, here's some random noise in a shape. AI, go do whatever you want with it. Keep throwing crap at the wall and generate something. And it'll generate that something based on the text that we give it. Again, so this thing tells it the text, and this is basically like the brain. And then the variation autoencoder will it's basically the vehicle. It helps takes all the information from latent space, which is the AI world, brings it out into the pixel world or images that we can understand, and then this node just basically saves the image or at least shows the image to us. So now let's jump into our AnimateDiff workflow. Boom. Okay. Looks very complex, but we're going to break it down so that you guys have a pretty good understanding of this, so that you are able to go and generate play with this, tweak it so that you can get stuff out of it. This can be very useful if you understand what's going on. And so that's what we're going to do. We're going to break it down so that you have a good understanding of it, are able to produce things, make the changes you need to make so that you are able to get the outcome that you want. Now, you don't want to end up spending way too long in here, because I definitely spend way too long here, but this is why we're going to provide you with these workflows so that you're able to just go ahead and get going straight from the jump. So let's break down what AnimateDiff actually is doing. So if you think about how traditional animation is done, old school cartoons, is that they're basically taking images and they're chaining those images to create some kind of a movement. So if I wanted my hand to move from here to here, someone would have to go through like a flip book or like some kind of paper and draw each frame by hand. So each frame by hand so that it looks smooth as like a flip book, right? Like, so it looks like I'm actually moving my hand from one space to another. That's what AnimateDiff is actually doing. Again, it's turning images into animation. And the way that it's doing that is instead of you basically doing like the flip book drawing frame by frame, it's going to figure out how to do that so that the animations look smooth throughout the timeline of the images. AnimateDiff does a really good job of understanding like how does one frame look in comparison to the next frame of the series of frames in that particular animation. So like if my hand's moving from here to here, how do we make sure the positioning is consistent so that it looks like I'm just actually moving my hand, something that makes sense. Like the AI community has been struggling with up until this day is the glitchiness, right? The glitchiness of different images. Because whenever like you'll end up with different shirts or different hair colors, or like, you get random arms generating in different places. That is what AnimateDiff is trying to solve. It's trying to make sure things are consistent, things are the same size. We don't get random limbs appearing in other places, so that AI can understand if the person frame by frame is moving, if they're the right size, if they're the right placement, the right kind of movement, right? Like that's what it's trying to understand. So that is AnimateDiff. This looks like a mess. And the way that I'm going to start out is basically explaining the very simple things that we were just looking at previously so that we have a pretty good place to start, right? We're going to start with like, well, what were the nodes that were in the default workflow? And so one thing that you should know is that part of the reason why it looks so messy or looks like a lot is because we're breaking things down into smaller components so that we have more control. But we've got our normal checkpoint loader, which is our brain. We've got our clip text encoders, which is how we talk to the AI, right? Takes our text, puts them into sends them into the AI latent space. We got our sampler, which is, again, everything happening behind closed door, the black box, the noise that's happening. And then we've got our variation outer encoder, which takes stuff from the AI world, brings them into pixel space, from latent space to pixel space. And then we've got our save node and another video combine node here. The one thing you notice that we don't have is an empty latent image. And that is because what we're doing is a video to video. So with AnimateDiff, there's actually two ways of doing AnimateDiff. You could do a simple, just like text to video, where what you're doing is actually you're leaving out a number of things, right? But you're taking your text and you're gonna push it through AnimateDiff, and it's gonna generate, the number of frames, right? That at max it can generate 16, but I think you can choose. So if you say we're going to generate 8 frames of an animation, and it will try to take whatever we described here, and it will generate a video out of it. Or we could do a video to video, where if you are looking for a way to basically control how different movements are, right? You want to take some other movements and you want to create a video out of them, change the style, you know, change just the faces, whatever. This is the way to do it, video to video. And so that's what we're doing. The text to video is pretty simple. So if you understand this, you will understand how to do the text to video. We've got our brains checkpoint loader. We've got our text encoders, which talk to the model, talk to the AI. We've got our samplers, which is how the AI does its magic. And then we've got a way to load the video. So that's the very first thing that's going to be different here, right? From the normal default loaders or normal default workflow. The very first thing is, how do we get the video in there? We've got our video loader here. And if you want to see what the node is, you can always right click and click this panel to show up, because it provides a little bit more information on what the node that's being used is. And here it is. It's the VHS load video node. Okay, so we're loading our video, and then we're moving to this node, which is just an upscaler, just as it sounds. So we're just going to make our video a little sharper. All right, you'll notice that we've got deciding the width and the height. We were doing this on the empty latent image in our previous workflow, but here is where we're doing it. So instead of us telling the AI, here is dimensions for an empty image or just noise, we're going to say, here's a video, here's a bunch of images, and we're going to shape them to be this size, and then we're going to make them a little sharper so that the AI can understand. And then again, variation auto encoder encode is going to take all of our images and send them, turn them, make them so that they can go into the AI space, into the latent space. And that's why you got latent coming out the other end. So we're going from pixel space to the latent space. And again, before we had a variation auto encoder that came with the model, but this is just a node. Like some people like to have a generic model. So we're using this SDXL variation autoencoder, which is pretty generic for it. You can use this if you want. I haven't seen much of a difference to it, but we'll keep this generic one for now. You can use this one if you want. But we're just going to keep it simple. Okay. So we've got our VAE loader, and it's helping us take the images that we're getting from the video, sending them into the AI world, AI space. And then we go into our case sampler. And yes, we have two samplers. It's not really a case sampler, it's a custom sampler. But we have two samplers. And that is actually the special part about this AnimateDiff workflow. There's two parts in this. This first part is the unsampling. So what normally happens is we're taking a bunch of information. So we're taking this text, we're turning into something the AI can understand. Then the sampling is the part where we're throwing crap into the wall. It's like if you throw crap at the wall and something sticks, those specific things that stick earlier on have a way bigger impact down the line. And instead of leaving that to random chance, some other genius out there also figured out, why not take an image, turn it into noise so that we can start to guide that noise to come out the other end, and we have more control of that noise. We're taking noise and we're sending it into the AI world so that that can help us guide that process of throwing crap onto the wall, instead of just hoping something sticks and then like we go with it, or instead of just telling it what to do so that it can like try to figure out based on our words, right? Because like we're not as good at talking to the AI quite yet. Like we don't fully understand what's going on in the latent space. And so we've tried to help it by just sending noise that is already the shapes of our images. And that's why we're turning images into these noises, and then the noise goes straight into the sampler, into the AI space, latent space. And then we start from this. So we're starting from somewhere. Okay. That is the first part. And then the second part is actually where we are resampling it, right? So instead of turning pixel or turning images into latent, going from image to latent space, we're now going to go take the noise that we created, right? So as you can see that the noise already starts to look like our video, like our person here. And so it's going to take that, it's going to run with it, and it's going to be a lot closer to this than it would be otherwise if we were just sending a text. That is the purpose. And again, we've got a decoder that goes from the latent space to the pixel space. And boom, this thing helps to show it. The preview image shows it. K sampler. Right. So if we're looking at a K sampler here, you can see we've got a model, a positive prompt, negative prompt, and then we've got a latent image. So instead of a latent image, we're actually turning an image into latent space, and then we're going to push it into here instead of doing random noise, right? And we've already shaped our image before. And so the next thing here is really the sampler. And that is what we were picking when we were doing this. So instead of, like I said earlier, like we're breaking this down into like mini parts so that we have finer control. So instead of our sampler, we're actually just having something else that selects it. So instead of like the Euler that's normal, I'm actually doing just an LCM sampler because I want this to go faster. And then you'll see that we've actually got what's called like a sigmas, which is how we control our noise generation. Yes, we're already putting an image in there to help us shape the noise so that we can generate more consistent images. But this is actually how that noise is generated. And so you can choose, your SD 1.5 or SD1s, you can choose your XL, or you can choose the stable video diffusion model. And then we've got our steps, which is just like how many times the AI throws crap at the wall, right? Here we're doing 10 steps. So 10 steps. And then denoising, this is like, if we're doing an image, normally this is 1. But since, we're getting some pretty strong reactions from doing an image, from the unsampling, we can actually play around with this and move it down this far, also depending on your model, right? The model that you're picking. For my case, I'm actually picking, so I've got this like blue pencil XL, which comes off of like the Animagine series, just trained with like a blue pencil. So this is the blue pencil model. I like these a lot. I kind of like the look, the aesthetics for them. I think they do pretty good. And then this is an LCM version of it and Lightning. So you can go and check these out. I'll leave the links below. Jumping back into this. So this is our sigmas, or basically how we sample how we can control our sampling. Again, our LCM. So we'll go right back into here. Here's our CFG still there. So the higher the CFG, the more control you have, or at least like the more it'll listen to your prompt, The lower it is, the more the model will decide. I'll get rid of this. And then again, so this flip sigma is taking, since we're doing an unsampling, it's going to take all the stuff that we would normally have done and it's going to flip it so that we're going into the AI world instead of coming out, right? And then we're doing the same thing here. Here is kind of here's our positive prompt and negative prompts. This is just a little bit different in that like we're using this like special one for SDXL because we can kind of combine. So instead of writing one long prompt, we can use these two so that it won't mix a lot of our words together, right? So like sometimes you put like a red hat. It'll also have like a red shirt or like a red background. This is a way to kind of help separate some of the stuff. So I could put like anime, masterpiece, flat colors, and it won't mix them with these as much. That's why we have this. And same thing here. And of course, you can control the width that you're doing, width and height that you're doing with this, and a couple of other stuff. So it gives you a bit more control. You can kind of leave a bunch of this as default, and you'll be fine. The other thing that is different from the default workflow is the ControlNet. And so ControlNets are a way for us to help guide the generation. So I'm using this line art ControlNet. And again, the model, you can just go straight into our manager, custom nodes, and go straight. You can just do control, if I can spell. And the ones that I'm using are these ones. Yep. So that's the node for it. And if you want the models, you just go into the model section. You can type ControlNet. And then I've downloaded a couple of these, but the one that I'm using are actually these ones. So these Zensor ones are really good. Like they're pretty good ones. So I'm using this anime one because I think it works really well. You could also use the this Death one, Kenny. Here's another Scribble. Bunch of other ones that are there, but those are good. We also have again, we're looking at our custom nodes for video suite. Video. Here's our video helper suite. Again, so I'll have this workflow available for you guys, but just wanted to show you guys like all this stuff you can basically download from here. And then I'll leave the link for some of the models that you can't download from there. But this is the model that we're using. We're using a line art preprocessor. So we're taking these images, which are a much easier way to control what we want, and turning it into something the AI can understand, and then we're putting it into the heart. And this is the resample. So that is what ControlNets are doing, but we're using line art ControlNets here. Now let's jump into AnimateDiff, which is kind of what this tutorial is on. So this is the AnimateDiff. It looks a bit more complicated, but that's because, again, we're breaking stuff down. But let's just go over it. So we have this is the sampler for the AnimateDiff. And again, you can just go into Manager, Custom Node, and if you type in AnimateDiff, you want the evolve one. So you can just go ahead, click it, and install it, and you should be good. Now, there are some things that you won't be able to get. So if you do AnimateDiff, you want to also download the models that the AnimateDiff is using. And so they've got models. So I've got one here for SDXL. So this is the SDXL one. And then there's another one for 1.5 V2. And I think there's actually also a V3. Yeah, right here for 1.5. Mostly the biggest difference between using 1.5 AnimateDiff and using SDXL is that there's a lot of stuff that has already been done with SD 1.5. And so you can kind of have a bit more control. But the 1.5 models don't really have very good understanding of context. So like if somebody's pointing a gun, it might not understand like, oh, that's a hand holding a gun and it's gonna generate it that way or draw it that way. That's why, I like the SDXL a bit more because you get better context with your generations. But we're not even using those ones. I don't think this is actually on here quite yet. Actually, let me just search it up. Hotshot. Yeah, it's not here. But I'll leave the link for it. We're using another one. So there's a new motion model that has just come out called Hotshot. And right, so just like our case sampler, or not our case sampler, our ControlNets have their models. This thing, our AnimateDiff also has its own models, and we're going to be using this Hotshot one. Normally we could use something like that's like square linear, or it can auto select based on like whatever other stuff we provided. But the Hotshot model recently just came out. Like you can find more here, but this HotshotXL was trained on GIFs. So it's basically, the idea is to make GIFs from text, and it's trained on like only eight frames per second GIFs, which is a little bit more different than our, right? So here it is, 1 second GIFs at 8 frames per second. This is just a faster thing for loading the AnimateDiff model, or at least it'll help us apply it. And so we're gonna go here and we're gonna pick this HSXL temporal layer, because that's what we're using. We could have used this model, which is one of the other ones that we downloaded, or the diffusers. These are the 1.4. This is actually the SDXL. The 1.5, if that's the one you're using, if you're using a 1.5 model, you want to use the 1.5 AnimateDiff model. But we're using an XL, so we can use the HSXL, or we can use the SDXL. In this case, we're using this one. There's also some other options here. So just like you can train LoRa's for like just regular checkpoint models, you can train LoRa's for AnimateDiff models. And so this can give you more like finer controls of what kind of motions you want. So you could have like I've only downloaded 2, so we've got a pan left and a zoom out LoRa, which could help you. So you can train these. Like, I haven't done much of this, which I definitely should. And as things get better and better, I think these are going to become super powerful for people to end up using. But we're just going to leave that off for now, keep things simple. So we've got our AnimateDiff, sampler, which will take a model, and we're going to choose our model here because we like to kind of spread things out. Like, this is where the heart is. Like, this is where all the important things are for AnimateDiff. And this is like the context options. So if we're thinking about AnimateDiff, right? AnimateDiff is looking at a context of like 16 different frames within a motion. And it's looking at each of those frames and is saying, how do everything look so that it can generate the next frame so that it looks consistent, so that it looks like it's in the right place, so that it looks coherent to everything that's happening. It's not just a limb popping out of nowhere. That's what all of this is actually helping to control. So AnimateDiff is trained at 16 context length. And so we're taking 16 frames. Then you've got a context stride, which is, this would be like if you're walking on a beach and you're picking up pebbles, this would be like how many steps you take before you pick up a pebble, right? So if your context stride is larger, then you're taking more steps before you end up picking up the pebbles. In our context, the context stride actually is looking at the number of frames. And so in this case, I'm looking at each frame and I'm doing stuff on each frame, but I could easily go with two. And so that way I could look at uh, every other frame and decide how I'm going to generate the next frame, right? Uh, and then we've got an overlap, and it's just as it sounds. The overlap is if we've got 16 frames that we're looking at each time, then we're overlapping, in this case, we're overlapping 4. So that means that out of 16, we've got 12 that are ones that the AI have not seen, and 4 of them is going to try to match it from, the one batch of the 16. So if we've got 16 here, 16 here, it's going to smush 4 of them together so that those 4 are essentially the same, right? And then the pyramid is just the method for how it does the smushing or like the fusing of the different frames as it's generating them. A lot of the stuff you can kind of leave the same, but like it's really good to know them so that you can tweak these as you're going. Guarantee step, like a lot of the stuff I just leave. So the important stuff are these 3: the context length, the stride, and the overlap. And then we've got settings. A lot of times, like I don't really mess with the settings all that much. Like, how many batches you're loading. Like this is, you kind of just leave this be, and you're good to go, really. And so that's the crux of AnimateDiff. And we're doing the exact same thing over here when we're resampling. It's just we're actually taking the same information. As you can see, there's 2 things coming out of here. One's going here and one's going to the other. Right? So we're doing AnimateDiff models and settings here with this sampler, and we're with the unsampling, and we're doing it with the resampling. That is the gist of our workflow. And then once we sample or once we do our resampling, we use a VAE, take our stuff out, and from latent space to pixel space, and then we're right back. As you can see, the images, like, they look pretty close, right? Like, and the crazy thing is, I'm doing this at only 55% of denoising. So I can make this like a full one denoise the entire thing, and boom. So as you can see, if we leave it to do like 100% of the denoising, as it's generating, as you can see, like it'll keep the shape the same. Like that's what the ControlNet does. Is really, ControlNets are really good. Their main purpose is like to make sure the shape can kind of be guided. So it's taken our helmet and it turns it into just this bowl haircut, right? Like, because like it goes based on the initial noise, like whatever is happening at the very early start, then it just tries to form it. And we, based on our prompt, right? One boy, solo, coyote color combat uniform, black hair, closed eyes, sitting, art style, and with studio, rubbing his face. There's nothing in here that says that he's wearing a helmet, so it didn't get that, and it turned the helmet into this weird haircut. It does a pretty good job with the clothes, though, as you can see, right? Like, and this is, we're using what, we got 8 frames here. And so like normally you would see some like, flickering or some going back and forth, and like, nah, none of that. But it is starting to make some mistakes. And I think it's just the model actually, where you can see it's starting to make mistakes on the hands here. but I think that stuff we can fix easily. There's been a lot of work that's done on fixing hands, so I think we'll take this, but we're just gonna soften it so that it's only generating at like 50%. So we're gonna change this to 0.5 and go. Sometimes like if you make the denoising too low, then it just kind of paints over it a little bit and it doesn't look as good. So there's just something to be careful of. So we're back. See, like, oh, this thing hasn't changed it, but as you can see, like 0.55 is a little better. It's not even changing it all that much here. It still kind of looks pretty similar. I mean, it's just a little different. But you get the idea. So I think that does it for our video. If you've got any questions, I'm always here. Feel free to ask. We'll actually be pushing this video to a community inside of our school. Yeah, where we'll have lots of conversations, calls. So feel free to join there, or message me on X or Twitter, and I'll be sure to get back to you. Thanks.